Well, let's get started. All the panelists are here. All right, so now we are going to have a panel discussion, frontliners and next frontiers of statistical computing and data science. Let me first introduce myself. My name is Chen. I'm an associate professor in statistics at the University of Connecticut. I'm also serving as a program chair-elect for the ASC session on statistical computing. I'm one of the co-chairs for this mini symposium. It's been great. I mean, I enjoyed the talk by Professor Bates very much, and also the data jamboree was fantastic. So my job today is simply to facilitate conversation between four brilliant and distinguished guests, and also, of course, between them and you, each one of you here. The main goal of this panel is to showcase exciting and diverse perspectives from statisticians and data scientists leading the way in all things computing. Our discussion today will cover two main topics. The first topic will be on career development in data science, especially those statistical computing related positions and careers. You know that this symposium is really geared towards students in statistics and data science, and to those who have strong interest in computing. So we want to showcase many possible career paths available and many exciting emerging directions in data science and computing. So hopefully this discussion will help our younger generations here to better prepare yourselves in job hunting and career advancement. The second topic is a bit broad, and we want to discuss the challenges and the opportunities facing the field of statistical computing. Especially, we want to hear from our panelists about their visions on the future of statistical computing and perhaps statistics in data science. All right, so first, let's get to know our four panelists. I will just briefly announce their names and current positions. We have Hannah Frick, who is a software engineer and Posit, used to be known as RStudio. We have Haoda Fu, who is an associate vice president, enterprise lead, machine learning and AI at Lilly. We have Eric Kolaczyk, professor of statistics and inaugural director of the Computational and Data Systems Initiative at McGill University at Canada. We also have Teresa Sönmez, who is a biostatistician, quantitative scientist from 23andMe, a company leading in genetic testing. So instead of me reading their long bios, I'm going to ask each of our panelists to introduce yourself. Since we are going to have a discussion on career development, please describe about your career trajectory, whether there were points in your career path at which you made a choice of direction, and what influenced those decisions. This question will be for each one of you, but how about we start with Hannah? Hannah?
Right. Hello. Can you hear me well?
Yes.
Okay, good. So I'm a statistician by training. I did a stats BSc and MSc in Germany, and I liked the research, but I wanted to do more with R. So I did a PhD with Achim Zeitleis in Austria, and that was sort of on the intersection of statistics, psychometrics, and statistical computing. And I wasn't quite ready to let go of academia after that, and did a postdoc at University College London, where it was a bit more applied. So that was like a project together with the British national team in field hockey, sort of run up for the Rio Olympics. And but then I was ready. So I decided to leave academia because it felt like academia didn't particularly care about the computing aspect for a statistician. I did not particularly care about sort of the side effects of, like, for example, moving wherever you get that one job. I think if sort of the role of research software engineer had been clearer at the time, I feel like that's kind of emerging at the moment. I might have done something like that. But instead I did a bit of data science consulting just to get like an idea of what working in industry is like. And then So during sort of the end of my postdoc, I joined the Our Ladies London chapter and then ended up co-founding the global organization, which is sort of like the backbone and the infrastructure for all the chapters worldwide. And I think I learned more about working in industry there than at my consulting job. And yeah, about nearly 2 years ago, I joined Posit, what was our studio then. And I'm back at very much working on the intersection of stats and computing because I work on the tidy models team. So that's my trajectory.
Oh, that's nice. Very colorful career path. Um, Haoda, you're the next.
Okay, so maybe I started my childhood when I was in the high school. I really like computing. I attended some computations, and actually I made my mind when I go to college, so I will choose computer science as my major. And my father was a statistician. He influenced me to become a statistician, so I was an undergraduate. So I joined the University of Wisconsin medicine in the 2000 moment. You know, the Wisconsin is very cold, and in the medicine, the computer science department and the statistical department in the same building. To fulfill our PhD point, we also need to choose a minor, and then of course minors, and because save some travels and in the very cold winters, I feel like a very fortunate computer science, in particular on the numerical optimization, in the linear optimizations, non-linear optimizations, and that will have a lot of influence for myself in the later on for my careers. And then I chose my minor as a computer science and a PhD in statistics in 2000. After the Eli Lilly and company reached out to me, they offered me a position. So I joined Lilly. I very enjoyed doing the research through my careers, and I published probably right now about more than hundreds of papers, and get a fellow of American Statistical Association and get a fellow of IMS, and so I'm also kind of in the incoming editors in the series method editor. So in general, I like doing the research through, and also through of my develop kind of careers in the past 15 years beyond doing the research. I really enjoyed doing the computation. I like the low-level programming, the SG Boost. I'm one of the contributors for the SG Boost, and I'm also kind of involved with a deep learning program, open source AlphaGo program. Right now they call it KataGo. The KataGo is really broadly used a deep reinforcement learning algorithm play the Go game, and many of the professional players are using this. I'm heavily involved in that community. I'm the second contributor of the KataGo programs. So later, that's it. And during the lead, I also broadly collaborate with different academic organizations. So right now, I'm leading Lilly Enterprise Machine Learning Artificial Intelligence group. In our team, I have like a 27 PhD in the US with different disciplines, including the statistician, computer scientist, double E major, and operation research, applied math, and also pure math. Some people in our team work on the high performance compute. People work on the high performance computing, different types of algorithms. So that is my team and myself, and in general my careers.
Thank you, Haoda. Eric?
Sure. Thank you, Kun. I'm Eric Kolaczyk. I'm a statistician by training, but I think it's because I have typically embraced a bunch of other intersections that my career has been particularly interesting to me personally. And to Hannah's point, although I did find my initial first job, I ended up finding that first job wasn't necessarily the only job, and that also has kept things very interesting for me to sort of selectively find that there's sometimes a next first job and a next first job. So in a little more detail, I had a pure math background as an undergrad, went into statistics because that was one pivot point for me. I thought, well, I want to do research, but probably not in mathematics. When I came out of my PhD, I had found myself working at the intersection of statistics and wavelets. And that was another aha moment, because that was right when that world was forming in terms of that area. And there were applied mathematicians and engineers and computer scientists and statisticians all gathering around this topic at once. Computing played an important role because efficient algorithms was very important at this time. So that kind of formed my perception moving on. I worked for a few years at University of Chicago and then transferred to the Boston area, where I was for about 25 years. I was at Boston University, where I continued working on wavelet type methods, but then around the early 2000s was itching to do something different and started hearing about this stuff called network science, which also didn't have a lot of statisticians in it at that time, and had a lot of physicists, a lot of computer scientists, a lot of domain area people, biology, computer, network traffic, what have you. And that, again, really is part of what made it very interesting to work in that area as a statistician. From an administrative point of view, as I got older, I'm just shy of 55 now, so eventually I was doing things like running the statistics program at BU. In my last few years there, I ran their Institute for Computing. So that allowed me to take the sort of collaborations that I had been doing for my own research for many years, and I needed to do two things. One was scale them up to a university-wide level, and two was really to facilitate collaborations, not so much for myself anymore, but for people across the university. So I found that very satisfying. It was sort of a change of role, but also a change of order of magnitude in the sense of what I might be able to do, leveraging skills I felt that I had been able to develop. And then my latest pivot was to move this past summer to McGill University, where they had sort of carte blanche, a new open landscape on data science and institute, and they're starting from fresh. And I've always known I like starting things in the ground floor. So it's been a lot of fun going to McGill now and taking, again, skills and ideas and experiences that I've had and matching them with people here and trying to see how we can do our best work together.
Oh, that's great. Yeah, your new adventure must be very exciting so far. So, Teresa?
Yeah, hi everyone. Thanks for having me. So I work currently at 23andMe. I'm a biostatistician there. I did have a little bit of a wiggly path, I guess, to get there. I actually started at UConn. I really loved math and statistics, and
nice.
I had no idea what I was going to do with it. So I was just taking math courses and taking stats courses. And one of the professors there at the time, I don't know, actually don't know if he's still there or where he's at right now, Dick London. He found me. He was the head of the actuarial program there, and he was like, come, be an actuary. And I was like, I don't know what an actuary is, but I decided to take some courses, and it was a very well-run, organized, structured program, and it was exactly what I needed, was like organization and structure. So I joined that group, and ended up moving to New York City to work as an actuary. It all was great, except for it wasn't great because I really was not interested in what I was doing. And I thought everybody was not interested in what they were doing, all of my peers that I worked with, but they all really were. They really loved it. So I thought it was time to maybe think about what else I might do, and what I was really interested in. And I really, I was interested in the health sector and the health space. So I thought about what type of degree can I get in that space, and that's sort of how I found biostatistics, I would say. So I got my PhD in biostatistics. It was housed in a statistics department. So our curriculum was really it was the statistics PhD curriculum plus take some, epi courses or biostat courses. So it was really grounded in statistical theory. and not so much computational statistics and not so much data science. And actually, as I was so much changed from the first year of my program to the last year. Like towards the last year, data science really became this term, and we realized, I think the stat department realized, we need to like start building out that program too. So I worked with Duncan Temple Lang. He's one of the founders of R originally. He was at our in our department, and he started just building out this data science group there. Just for those who are interested, and so I luckily still learned a lot before I finished. Anyway, so I finished my PhD in biostatistics. I was working, my advisor was a statistician, but she was in the public health group there, and we worked in Alzheimer's disease research. So I did about 5 years of Alzheimer's disease research, and that's a really interesting statistical questions you can get from that type of data. I guess I won't go into that too much right now, but just to quickly sum it up. So after I finished my PhD there, I did a postdoc at University of California, San Francisco, and I was really the only statistician in a group of epidemiologists, which was excellent in a way because I really learned all of this epi that I didn't learn, that I just wasn't exposed to. I realized they're answering similar questions as biostatisticians, but they speak a totally different language. So just learning that lingo was really helpful for me, and just learning the way they see things. I was pretty sure I didn't want to stay in academia, and I can get into all those reasons maybe during the career development part of this, but I actually went to 23andMe because they had a conference there on the future of phenotyping. So they're known as a genetics company, but I actually work mostly with non-genetic data. So I work with a lot of the non-genetic risk factors for health. But yeah, so I was supposed to write a grant, and I was like, I needed to get some ideas. So I saw they were having this conference there. So I thought, I'm just going to go there and see what other people who are working in the same space are working on. Mm-hmm. So I went to this conference, and it just really blew me away. They have like the type of research they were doing there. There's a research institute inside 23andMe that's really working and answering the same type of questions we were looking at UCSF. So yeah, I went to the conference, and I thought, I'm going to apply for a job here. And within a week, they posted a job for a biostatistician, and I applied, and it was like that. So it wasn't like that, but it felt like that. So I've been there for about 3.5 years, and that's my story.
Yeah, this is fascinating. Actually, I'm with you. I mean, I myself also had a wiggling past. I majored in finance and computer science, but ended up as a statistician, and I also worked as an investment analyst. Apparently, I didn't make much money, so I
now in
academia. So yeah, but it appears very important that you make good career decisions. So now let's formally start our discussion on career development. So we want this to be a conversation. So I may pose the question to one of you in certain order, but anyone, please do feel free to jump in if the topic interests you or you want to just add some comments. And also for the audience, please post your questions in the chat, and I will be monitoring those as well. And I will make sure that the most difficult and challenging questions are directed through to the panelists. All right. So let me start with my first question. This is an easy one. Well, let's start again with Hannah. So how you spend your typical day at work, and how do you like the most about your current work? Or if you may, how do you like the least about your current work?
So I have very few meetings, and I'm a little ahead in time zone of my colleagues, so I usually have a morning that is pretty free of distractions, which is lovely. So Posit has like a focus on, or well, an emphasis on focus time, where you're supposed to be, like there's room for you to say, I'm blocking off this amount of time to actually put my head down and think things through, without being pinged by everybody all the time. My team is small. I don't interact with that many people, so I have that almost naturally built in. And I get to work across all of the tidy models packages, some more, some less. So I'm mostly working on extending support for survival analysis in tidy models. And sort of in the afternoon, I might have meetings with my teammates, smaller team tidy models, wider team sort of tidyverse and others. Yeah, so I have a large amount of autonomy, which I quite enjoy, and like both in how I do things and what I work on. I mean, it's obviously coordinated, but it's nobody's being micromanaged in that sense. And the other thing I really like about this is that I get to work on open source, which is then available to a wide variety of people outside. So that's pretty neat.
That's nice. Someone in the chat mentioned that no meetings and well, lots of freedom. Like you also have the benefits of being in academia. Seems like
it is a little bit like that, and I consider myself lucky because I'm not sure how common that is, but it occasionally feels a little bit like a research group, although we're not necessarily doing research. But yeah, most of the people have had an academic career, so they're not unfamiliar with that way of working.
Nice. So, Haoda, do you want to go next?
Sure. So you want me? So in general, I was thinking is there are always I see three kind of people working in the company in the environment. So I start to make my comments also related to meetings. So the first kind of people is
So Haoda,
himself like the planner.
your connection is maybe unstable. Perhaps you can turn off your video. Maybe at least your voice could be.
Yeah, let me turn off my video.
Yeah.
Okay. So let's see if it works better. So I mentioned that in general, three levels work in the environment. The first is I call the prisoners. Prisoner, they think about themselves and the kind of my side, they think themselves is kind of the passengers. The passenger just follow other people's the passenger. The third way of things is explore, just continue to learning, the growing themselves, growing the knowledge. So I think it can either relate to the meeting. I just make the comments in the meeting. I'm thinking even for the same persons, they can be in different mindset at a different situation. So one part is, for example, if we attend the meetings in 2 hours, I have to be there, and then I just multitasking, and then maybe I will become a prisoners in the meetings. But on the other side, we can make our choice to become an explorer, and so leverage the meetings, talk with the people, learn from others, and to grow knowledge. So in general, I'm thinking it's important for me, at least for me, the mindset is how can I continue to maximize what I would like to do and minimize what I don't like to do. And in particular, for example, sometimes even in the meeting sessions, instead of thinking about self, for listener, how can I turn myself become an explorer and leverage the meetings to grow myself? That's my general kind of suggestions for my younger versions of myself.
That's nice. Yeah, I think, well, I think definitely everyone should learn some tricks to skip the meetings you don't want to attend or just make the meeting time more efficient. Yeah, that's nice. So maybe I can just turn to Eric. Eric, you want to share about your thoughts on this, how you spend your day at work, and what do you like the most about your current work in academia?
I probably have two types of meetings on my calendar, right? I have the types of meetings that correspond to what people usually think about as an academic, which is when I have classes, when I have office hours, when I meet with my research group or collaborators. a little bit of service here and there and whatnot, right? So that's sort of people's traditional view. Then the other part of my week, and that's very stable, right? So that's the type of thing you drop in at class time for the semester and you propagate it through your calendar. You put your group time in, you propagate it, and it's nice and very stable. The other part of my work, directing our new computational and data systems initiative here at McGill, that's like a startup. And so, my calendar 3 weeks ahead always has gaps around all the stable points. And, by a week ahead, that's all filled. What it's filled with is a function of what we're doing that week. So, when I came in the summer, we had 3 initiatives we were focusing on near term. One was to stand up a training program. So we have a lot of training on skills-based, data science in R, machine learning in Python, things like that, short courses. We have a support service that we stood up where we have statistical consulting, some geographical spatial consulting and whatnot. And then we have research teams that we're running research convergence exercises where we advertise for funding and research teams are coming. All of those have been just a whirlwind of energy with me meeting new people, dropping in appointments, planning with those new people, reaching out to other people. That's a huge part of the excitement, I think, of what brought me here to do this type of work is this very dynamic sort of feel. And next stage is also, just in terms of who we have on the call here, next stage is going to be looking at outreach to the city of Montreal, industries, both in the area and globally. So there's just sort of a host of things that will keep that part of my calendar very fresh for a long time, I think.
Yeah, wow, exciting. I guess data science is all about integration, right? So it seems like you have to put all different pieces together, interact with all different parties, people. That's really great. Teresa, so what do you like the most about your current work?
So for me personally, right now, well, I'll just start with work-life balance. I guess that's very important for me right now, and I I I feel that I have that. 23andMe provides really great work-life balance. It's very different from when I was in academia. So for me, I really appreciate that. In terms of the content of my work, I love the questions that we get to answer with the data that we have. I think we have one of the coolest data sets right now in the world. Aside from the genetic data that we have, we collect so much information from our participants on lifestyle, what they're eating, how they're sleeping, what their movement, exercise, all this stuff. It's an area I'm really interested in, non-genetic risk factors for different diseases. So it's an incredibly rich data set, and I would say almost my least favorite part about my job right now is just that we don't always have the time to answer the questions that we want to with the data. Or I think it's also just the responsibility of feeling like you really want to do something well with this data and not necessarily knowing if you can all the time. So that's
Nice. Thank you for sharing your thoughts. Yeah, I hear freedom. I hear I guess interacting with people, also work-life balance, and these are all important things to have. So now for my second question, so it's about let's say data science. So now people say this is the era of data science. Lots of people may agree that it requires a genuine integration of statistics, computational skills, computer science, and domain knowledge. So this is exciting, and we are making progress on tackling many difficult problems every day. But for students and for fresh graduates, I think there seems to be also more and more requirements because of this development. As a student who wants to pursue a career in data science and computing, he or she may feel overwhelmed at times. So that at least is my experience with some of my students. So the next question I have is, what are a few skills that you found the most important for your career success? This could be either scientific or non-scientific, could be soft skills, whatever you think that are the most important. Let's start with Eric.
That's a great question. In terms of feeling overwhelmed, and whatnot, I would say one of the most important skills, and it's not one that seems to come up in any class, is learning to have a little compassion for yourself. Because we're all fairly type A. If we're getting to PhD and whatnot, we're very competitive. We've gone through systems that say you can be the best, you should be the best, you know, etc. And you are very good, but you are going to hit challenges. You are going to feel overwhelmed. And I think with a little bit of compassion, sometimes stepping back, you can allow you to lean into the challenges rather than to feel like you're overwhelmed. Because it's leaning in that allows you to right size a piece of them. It allows you to reach out to folks who could help with another piece of a problem. It allows you to communicate with those around you. And come out of it feeling like you have definitely succeeded on the pieces that you're carved out. Life handing you many big things to do doesn't necessarily mean that that's right or fair or accurate. It just means that that's what showed up on your doorstep that day.
Yeah.
So, you know, data science on the one hand is so big and so broad, means many things to many people. On the other hand, I think that interface with statistics and computing, that's a really, really good one for our field to lean into. We're just seeing so much synergy at that interface. I think early days, both computer science and, you know, I'm putting my gray hair on there here. My early days, computer science and statistics folks kind of looked at each other a little bit and thought, I don't know. But I think it's the ones who leaned into the relationship that really have found, you know, the particular synergies that are driving just so much of what we see out there, so much of what we saw in the Jamboree, the type of stuff that's being talked about by Teresa and Hannah, and the AI that Haoda's talking about. But you can only bite off so much of it at a time.
Great. So who wants to go next?
Yeah, maybe I can come in for some next. I'm going to start with some of the hard skills that I feel like will be really helpful in the data scientist. Then after that, I talk about some soft skills. The hard skills and we train as statisticians, I'm thinking we already have very good background in data analytics. Beyond some traditional programs and some of the more emerging topics, for example, the causal inference, so that is become more and more important in the field of the data science. So that is the kind of in the statistics. But I want to comment a little bit more on the computer science part. So the first things I encourage our students to know the low-level language. So I through the years I found that if people don't understand the low-level language, they will have some trouble to understand the high-level language sooner or later. So can understand some low-level language like C or C++, and how this memory hierarchies, how this kind of this concurrent programming was going on, and what is like how amount of resource, like what is the R-value reference, what's the move thematic, what's the perfect forwarding. To understand this low-level language concept, that will help you for the long run. So this is the first component in the computing. The second piece is to understand some algorithm development. So their algorithm is how we can make computation it become more so in the different type of the different type of algorithm, for example, like the lead code problems, that will be tremendously helpful. I previously give one of the talk is on the topic is even we come out with the same algorithms, even for the dynamic programming, and some people program efficiently kind of millions of times faster than the naive way to solve the problem. That gave us a new tools, new way to solving some problems, and also have a good trainings on the algorithms that will also benefit for our software package statistical computing development. So this is a second algorithm development. The third component I also found it extremely helpful, but not many statistical students have the skill set, it better understand the software design principles, in particular for the design patterns. The design pattern is how the software design people is to abstract out on the different design pattern and to use a professional way to how to do this. For example, if we do a class, they only initiate one time, they call the singleton pattern. If they want to add the different functions, dynamically hook up with the class, they call the strategy pattern. Some like a decorator patterns, manufacturer patterns, they have different design pattern. Understand this design pattern and also different design principles like MVC principle, model view, the controller principles. That will helping us to write the code more professionally, and that will make you more easy to collaborate with other people. If your code is very difficult to maintain, so it will be very hard to work with other people on the large programs, and have this architecture thinking is very important. The last component in the computation is to understand numerical analysis and also mathematical optimization. That is another foundation for many of the statistical computing that will helping us to better understand the methodology, and that will also helping us understand the component of the statistical methodology. To name a few, for example, in the Lasso method, if we want to prove this kind of oracle property, they often use like a KKT conditions, leverage some understanding of the optimization. So that's the kind of the hard skills I wish I get more when I was in school and learn from our professors. Related to some soft skills, I think is also very important to kind of some of the hard soft skills I found is important for in the school and kind of get a job. But once you find a job, regardless you are in academia or in the industry, and you continue to grow yourself in the soft skill like communications but one thing is very, very important, really differentiate many of our peoples is how and build the trust. That is extremely important in how the whole society works. And to build we never learn how to build the trust in the school, but that's the most important things, how this society works and how you can work in the company setting. And so that's some of the general comments in the soft skill.
Well, this is very, very, I think, very relevant. Yeah, how to build trust, how to let people trust your work, right? Give you opportunities. Yeah, that's definitely very important. And also, I hear from you that Haoda, your work really requires your employee to know the core of computing and also those kind of algorithms, things like that. Yeah, I think if you are going to interview at the Haoda's group, be prepared. I mean, he give you lots of topics that he might ask you about. Let's hear from Hannah and Teresa. See what you recommend or what's your thought on the most important skills to have.
Yeah, I think it might be good to remember that data science as a field is pretty new, and sort of the feeling of being overwhelmed because there's so much and like it's not that well defined. That's because it's relatively new. And I think those specializations and clearer definitions will follow. And in the meantime, you sort of like make your way through, but it also means there is a certain amount of leeway to stitch pieces together that you're particularly interested in. And I mean, there's so many skills that you could learn. I don't necessarily want to make a point about which ones you should learn. But I think what is really helpful to remember is also to think about how you learn. So I've learned a lot of the things that I needed to learn from the people around me. And having a community of practice that you're part of, I feel like accelerates your learning and your career in general because you get to know people. And like I found that tremendously helpful.
Thank you. Yeah.
So for mine, I think I'll focus a little bit more on the soft skills. I don't even know if maybe this is not just considered a soft skill, but being able to communicate your communicate and summarize your work, I think is in short and concise and reachable ways, I think is really, really important. Especially, I've noticed that here where I work, but also in academia too. You know, we get so focused on, or at least I would get so focused on the work that I was doing, but I never really put any effort into whether or not I could present that and explain it to other people in the room. You know, I could always explain it to my really close peers or to my advisor because they knew exactly what I was working on. But you know, it's very important to be able to communicate your work and I would say that, and this sort of is in that same space, data visualization in general, really focusing on making your work accessible through visualizations or through different applications. I build a lot of Shiny apps, for example, because you know I do a lot of I'm creating a lot of results, but if people can't access them or can't understand them, I think that that's also a skill that I think is important to work on. That's more of a hard skill, I would say. But yeah, and the trust, I think the trust is really important. It's better to say no to work than to say yes to everything and then not get something done. So learning how to manage your time, how to say no to something if you don't think you're going to have time to do it. It's that builds trust. So that's part of building trust. Yeah, so I think yeah, those are my answers.
Yeah, thank you. Well, let's get to the next question. So now, you know, there are many opportunities for our students in statistics data science. You know, we used to say that as a statistician, we get to play in everyone's backyard. This is, of course, great for our profession, but for a fresh PhD or a fresh graduate in general, at the stage of job hunting, when you face so many choices and possible career paths or different, you know, you have possibilities to go to different industry like pharma companies or high-tech companies, it may not be so fun. So my next question is, I'm going to perhaps ask Hannah first, since you've been in both academia and the industry, from your experience, you know, what are the most important differences you see in working in different areas? This could be different scientific areas or business areas or public versus private or academia versus industry. And let's hear your thoughts.
I feel like we all sort of done a bit of academia and done a bit of industry.
Right.
So I think a lot of the like cliches are not necessarily true. I think like I've encountered autonomy and purpose in industry more than necessarily in academia, although that is usually a large selling point for academia. And I think you find these these sort of pockets of interesting, good jobs in a lot of settings, and I feel like picking one path does not like force you to follow that path for forever. There's a lot more possibility to move between, say, industry and academia or smaller and bigger companies than I perceived it when I was a graduate. I don't know if that is different for today's graduates, but like I thought I was like picking something and that's the trajectory for the next 20 plus years. I don't know. So yeah, I think Eric echoed something about a good first job and then another good first job. Obviously you want to like build them together so that they give something and you're not starting at zero all the time. Eric is carrying over his skills and sort of making that more interesting that way. But yeah, I think one decision isn't the final one and you get to try out stuff. And if this is not the right thing you picked, then do something different. Think about where you want to go and pick the next one that way.
Yeah, that's a great advice. Just one decision is just the first job, right? So it's not something that you have to keep doing for 20 years. You can always switch gear if you need it. Yeah, so let's hear from other panelists. What do you think about this problem? What's the most different important differences you see in different areas? Eric, you want comments on academia versus industry, or from?
I have to say that is a pet peeve of mine. I do not consider
the
a
beans.
dichotomy. Pardon?
Sorry, I muted myself. I said spill the beans.
Yeah.
Or if you pet peeve.
I think it's a false dichotomy.
Mhm.
Think about, being on one corner of one block and you want to walk 2 blocks down. At some point you cross the street and you're in the next block, but you're still on the street. It's still one long walk, right? So there is a sense of dichotomy and there's also a continuum, right? And so we've even heard on this call, right? There are research groups within companies that are essentially doing the same sort of research in academic life. There was jokes on the chats that, oh, you're essentially living an academic life. There are people in academia who are working very hard to create industry-like environments. At Boston University, we created a brand new master's program where the number one rule that I gave everyone when we entered the room was that I pointed to the whiteboard and I said, that's because we're not starting with our traditional master's program and tweaking it. We are going to just start from scratch and say, for a data-centric, practice-centric degree program at a master's level inspired by data science, what do we want it to look like? And we brought a bunch of things that are industry type stuff, including group work, including leaning into communication skills and various things, a whole list of things. And that's in academia. So I do feel that by perpetuating that perspective, we do both sides a disservice. Yes, it's one thing to be in a university. Yes, it's another thing to be in an industry. Yes, there are legal differences, structural differences, et cetera, et cetera. But I think by kind of accentuating those, we really do ourselves a disservice. And I think that for students, we're going to be serving them the best if we continue to break down some of those barriers and add more fluidity between them.
Yeah, Eric, I think that's a really great point. I think, the thing is, when you're in academia, and this is part of what you're saying that needs to change, is when you're in academia, you're surrounded by people who have had academic success, so to speak, right? So all of your professors have had academic success. And they are, I mean, often I've felt this. My husband, who also did a PhD in statistics, was feeling this too. You're getting advice from those people, so it's a little bit of biased advice. And there was a huge, I mean, I went to school, I did my PhD in the Bay Area, and it was, that's where you have all of this industry, but you also have all of this academia, and all we would hear in doing our PhD during that time was we were selling out if we went to industry. And it was like, everyone was like, somebody who went to go work for Google was a sellout. And you're like, I don't know if I didn't feel that way, but I thought that was really doing students a disservice by not merging those two together during the PhD. So that's, I mean, even in terms of the training you get, there's statisticians that I graduated with that felt completely ill-equipped to go into industry by the time they finished, and that's horrible. You have a PhD in statistics and you don't feel confident to go and work as a statistician somewhere else, somewhere out of academia. So I do think that I think that the academic programs need to really start opening those doors a bit for students more and merging those programs. So I'm glad to hear that you're doing that at BU. And I think also, like, for me, the biggest difference working at 23andMe versus at UCSF, even though like in so many ways my job is very similar. I have a lot of autonomy at both places. I had the biggest thing was I felt in academia I was doing so much thinking about like, how am I going to fund myself, and like writing grants, and that's going to be different depending, if you're in a soft money academic career or a hard money career. But it felt like, at 23andMe, we have this policy of getting to know fast. So you could be working on something and then you realize like, this isn't good anymore. I shouldn't be doing this anymore. And you're encouraged to switch gears. In academia, I felt we didn't have that option because it was really like, okay, you started this paper, now finish this paper, now get this paper out, because you need to get all these papers out so that you can get your grants funded, so that you can write more grants and you can have a successful academic career. And I mean, that's how it was in my head. That's not how it is in everyone's head, but yeah, that type of stress just wasn't anywhere you go, it's going to be stressful. There's different industry stress, there's academic stress. For me, the academia stress was just, it didn't work well with me, and what I wanted to focus. I felt like all I was doing was writing. I was writing papers, I was writing grants, and I wasn't doing enough of the other stuff that I actually did my PhD in. So yeah, that's my thought.
Yes, very nice, interesting discussion. Yeah, Haoda, please.
Yeah, so I was thinking about like from this conversation, I really enjoyed this conversation. I would just think about the two books, and these two books and related to kind of two sides of thinkings for here. The first book is called "A Crucial Conversation." The times to talk with stakeholders, regardless you are in the academia or industry. So the number one things in this book talk about the crucial conversation is don't make any assumptions before the conversation start. Just observe, collect the data. So I'm thinking it's like a statisticians, we like to collect data. These are similar things when you're in the new environment. It's important to observe, collect data before you make too much assumptions and to make yourself jump in some situation that you don't want to. This is one side of the story.
But
the second part, the one side of at least my learning through my careers when I was changing different groups. The second piece I also think is important is I like one of the book read by the Daniel Pink. If you search on Daniel Pink, the title is called Drive. The drive mentioned is why people is motivated to do the certain things, and so what is the ultimate in the work environment make us happy, regardless in which environment. He would talk about three things is very important. The first part is the purpose, find your purpose. The second part is the mastery, continue grow self, become the expert in area, mastery. The third thing is autonomy. These three things is really important, and through the research, they demonstrate these three is motivate people to keep doing the phenomenal work. I would think it's important in the new environment, if you change the environment, is find the purpose. Why you're doing this. Don't make yourself become prisoners and think about kind of you have to do something, and find the purpose. And make yourself see the growth opportunity, continue to grow yourself, become a master in the areas, and you can feel the accomplishment of yourself. And also seek some areas with autonomies, and that you can have to do the things that you really instead of really dictated by somebody else. So that is the kind of second part of my comments related to in a different new environment.
Yeah, these are great advices. Yeah, I especially like the idea of collecting data to make better decisions. And well, remember that you can collect data from others, and also you can collect data from yourself, right? You can try those different things by yourself. Yeah. Yes, great. So let's go to our next question. Because of time, we also want to get to the second part of the future of data science and statistical computing. So I think it's time, perhaps I'll ask each one of you to give just perhaps one advice to students, to those who will be or are already on the market, perhaps hunting for a job related to statistical computing and data science. What would be your advice to them? Who wants to start?
So maybe I start. I was thinking one of the suggestions for me is be curious, keep learning.
Yeah, this is a great one. Be curious and keep learning, right? Okay. I guess this is just remind the students that well, your learning process does not stop when you graduate, right? So you can still learn on the job and just keep learning and then keep getting better. That's a great one.
So are these students mostly undergrad students who have, are we
I
talking
think we
about?
have a mixed audience. We do have students, but these are I just say next generation statisticians and data scientists. So
Yeah, well, I guess in terms of, I'm just because we recently did a round of hiring, and I'm trying to think, what was I looking for when I looked at everyone's resume, which resume stood out, and you know, like, you know, your resume, of course, it's we get, you know, everyone is getting hundreds of resumes at any company or even academic positions or PhD positions, right? So you want to make sure that whatever you put on your resume does stand out. I looked for like right in the, like, I don't want to search. I don't want to like search through like lots of fancy words or writings or whatever. I want to know like right away when I look at your resume, what is your skill set? What can you do? What have you done? So even, I mean, this is just personally for me, this might be different for other people, but I looked at, you know, right in the beginning, like, tell me exactly like what hard skills you have, what technical skills you have. I think that really stood out for me. I don't know, you know, it's like an easy question that you just asked, but actually a pretty hard question. Like, what advice? You know, one thing that I did before I did my PhD was I looked at the jobs that I looked online for jobs that I would want, and I wanted to see like, well, what are those skills? Like, this is where I want to be, and what do I need to learn to get there? So, well before I was qualified for any of the jobs that I later applied to, I looked online to see what was necessary, and made sure I learned those skills. And I actually still do that now. Not that I'm like thinking to leave my job right away, but I'm always looking at different jobs and seeing what are the new hot skills out there that are being asked for, or that are on these job applications, and trying to make sure I'm keeping up with things. So that's my advice.
great.
Yes, I would say be passionate in what you do and try and find what you're passionate about. Right? Because if you're really passionate about doing something, if it really grabs you, you want to know the answer to those questions, you want to produce a product, you want to hit a milestone because it just really grabs you. That will carry you through so many things. And at the same time, if that passion isn't there, or it was there, but then it's kind of waned, you know, the project's gone a different direction, you feel like, you know, you're doing the same thing again, but maybe you don't like repeating that, then maybe it's time to do something different, right? And so I guess the other piece of the advice would be don't be afraid to do something different, to change, to pivot, I guess, or whatnot. And I say that, you know, not as just sort of in making a decision on your PhD program or your first job, but throughout your career. They say now that, you know, the number of jobs that this generation will have, you know, certainly even compared to my generation, my parents or grandparents' generation, yeah, I mean, going way back, it's a very different world. Used to be you would hope to find your one job that you would do all your life and then get a retirement package and blah blah blah, and you know that world doesn't exist. So lean into it, figuring that when the passion is not so much there, when something else starts calling to you, you know, give an ear, listen to it. Maybe that's your next step. Maybe it's not, but even exploring it can be interesting.
Great. Hannah, do you want to share your advice?
I think any of the advice, like from experience, always has like a good amount of survivor bias to it. And like what worked for me might not work for you, but I think a thing that works for me that I hope is relatively easy to translate to other people is sort of finding your peers. I found networking like to be slightly weird originally, but having peers that you do things with, that you exchange yourself about, like, makes it so much more fun to learn new things, to keep up with things, because they will bring stuff that they are interested in. They will point you to other people that might have an interesting opportunity for you. They might think of you when something comes up. You can be a step on the ladder for somebody else. So I think that is maybe the thing that translates best to others. So like mine was like our stats community on Twitter and our ladies, but there's so many pockets. If you're like looking for a more scientific thing, take a look at our OpenSci and all these communities to find people who are doing things you're interested in and are interested in similar things as you. So that helps usually.
Great, great. Yeah, so we have several questions actually from the audience. Let's hear from our audience. I will read the question and see any one of you can respond. So the first question here is, for someone considering graduate school and interested in applied statistics in a specific field, for example, biology or environmental sciences, would you recommend going into a statistics PhD or a PhD in that field and working on statistics-related projects? Who wants to respond to this question?
So my first thoughts on that are, it's, first of all, nothing is impossible. So it's, you know, you could do both, and you could probably same end point. But I think if you really want to work in applied statistics, that you should go and do a PhD in statistics or some version of that. And then during your PhD, you can you could focus your dissertation perhaps on something that is more in an applied area of your interest. It will be really hard. You'll learn statistics in any research PhD. So if you go into environmental sciences or biology, you'll learn some statistics to get you through the exact questions that are specific to that exact field. But you won't. My take is that you're not really gonna get the underlying theory that's really, for me, I find useful to do. To really extract meaning and information from your data, and to be a researcher in general. So I think that would be my thought. And it's not impossible. You can go and do an environmental science PhD and then really make sure you focus on the statistics and really like link up with the stat department there and try to your peers, most of your peers won't really be working in that space. So yeah, I don't know, that's my first thought, but I'm excited to hear from others what they think.
I think one thing I tell students, when they're asking questions like this, is you need to realize that the PhD programs are really two pieces, right? There is the coursework, and then there's the research. And in turn, those things are informed. The coursework is informed largely in most places by expectations of what it is considered to mean to get a PhD in field X, meaning you have to have foundations and knowledge and blah, 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 right? The PhD is somewhat informed by that. I'm sorry, the dissertation is somewhat informed by that, but it's more informed by the interests of the people that you're working with. Right. And particularly for people in undergrad who are coming out and beginning to say, oh, now I want to do a PhD, that's sometimes it takes a little while to get the head around it, because it's not just more classes. Right. And so it's really worth looking carefully at programs, right, and looking at what's the particularly cross-disciplinary programs. Right. If it's biology, if it's statistics, then those will probably have a certain look to them. But if they're quantitative biology or computational biology or something like that, there's a whole spectrum of how much compute versus biology are in those programs, and you have to kind of examine them carefully. The other comment that I'll just add to complement that is you also want to think a little bit of when you come out. Even if it may seem a bit off, where do you think you would want to be? Who are you hoping, and not just, again, to stress my theme, right? Not just that year after, but 5 years after perhaps, or even 10. And, again, that's harder to look down that road. But if you feel like, look, I want flexibility, I want to lean into biology now, but chemistry kind of interests me too, and I could work at a biochemical interface, or maybe sometimes I used to like finance. Maybe I want to go back. Then maybe you're suggesting general and keeping your options open. But if you're just like, I absolutely love biology, to use that as an example, then maybe either stat with bio or bio with stat, then that's worth looking at that interface. And that's just an example. You can take other fields too, but you have to do your research, and it's worth talking to someone to understand how things are organized and why they're labeled ways they are, so you can kind of understand what it is that you're making a choice of when you choose things.
Thank you. Yeah, this is great advice. Maybe we can just try to answer one more question and then we move on. We do want to save some time to discuss the future of statistical computing. So this one question is about how do you manage to stay updated, and what would be your advice on finding a question of huge interest to yourself? Yeah, this is asked by someone who is perhaps pursuing his or her PhD.
I guess I'll go again.
Please.
So how do you manage to stay up to date with everything with this expanding field? Was that the basics of the
Yes,
question?
and also how to find a question or a field of a huge interest to yourself.
Well, yeah, I mean, for that second question, and I guess in part the first one too, I think be curious. That was someone's advice in the beginning. Go and explore different things. Talk with other people that are working in this field. Don't feel self-conscious to reach out to any of us or anybody else on LinkedIn and ask them about their field. I think, for me, I found, I went to this conference one time at 23andMe to learn about what was going on, not even thinking I would be working there, just to pretty much do the same thing that you're talking about, which is find an area of interest, or find some ideas in that space. And I think talking with people about what you do and hearing about what they do, you'll be surprised at how fast you'll start to learn about yourself, and that can change. What you're interested in now can change to something else later on, but just keeping that open mind, and I think that's important.
Yeah, thank you.
Right.
So
I
yeah, please, Haoda. Yeah,
in particular, there's some systematic research on this topic. In general, the conclusion is read more and make the right friend is really important. So a lot of our ideas, when we are reading some other people's work, reading the papers, they can help us to stimulate our mind and our brain to making some connections. Innovation is the connection to making the things together. That's really important. Another part is important is kind of making the connections, like Teresa just mentioned, go to the conference and talk with the people. A lot of time you will be also motivated by some people, other people's talking with your friend, and talking with the kind of the expert, domain expert that will be inspired you. And through the years, I found this tremendously helpful when I would keep reading other people's work and making the friends and go to a conference. And a lot of time after go to the conference, I didn't feel like I'm so motivated on certain topic. After go to conference, I heard a new topic, I started reading the topics, and then make myself get deep into some areas. So that's the kind of my suggestions kind of on this topic.
Yeah, thank you. Yeah, so I think this discussion has been great, and I think we spend more time on we planned, but it definitely worth it, because this is for career development. I think it's extremely important for our students and the younger generations. But now let's switch gear and to talk about the next frontiers of statistical computing. I think this is also, of course, important for our field. I actually plan to ask you your definition of statistical computing, but I guess we can skip. So I'm just going to ask, based on your own definition of statistical computing, what areas of statistical computing are not getting enough attention, and what areas of statistical computing are getting too much attention currently? That's my first question. Who wants to start? So this is just asking, what do you think about the current status of statistical computing based on your own definition of which part is getting more attention or which part is not getting enough attention? So you can talk either one of the two.
All right.
So maybe go ahead.
Hannah, please. Yeah.
Okay.
Please.
I feel like sort of the increased importance of computing in general also led to an increased importance of statistical computing, which for me is sort of like computing's computational tools to facilitate statistics. But I feel like most of sort of the output of statistical computing that can be used more widely and can push the field forward is still coming out of academia. And my last touch point with academia is a couple of years back, so my impression might be a little dated, but I felt like there was still quite a long way to go to like fully acknowledge and support the importance of computational tools as part of research and also as research output. So I think that is something that could be better and would help better science.
Haoda, you want to go next?
Right. So I want to do next. I feel like statistical computing is have a lot of potential and a lot of areas they can improve. So one area I do want to see that is really bring the engineering mindset into the statistical computing. What I mean by here is why, if we think about at least in our teams in Lilly, why the deep learning achieved a lot of success. The deep learning achieved a lot of success. It's very easy to prototype the different new ideas, the new algorithms. So if I develop a models, I want to add some attention mechanism. I believe one thing connects to another. I just a few lines of Python code, and then I can prototype this and run my code. Half hours, I can finish my coding and to see some of the result in some small bunch of the data. But on the other side, think about if I'm thinking about if I added in the mixed effect models, I added the priority terms in statistics. I probably, if I use the EM algorithm, I need to myself to write down the likelihood. Probably it will take 1 week or 2 weeks. I can get some simulation result. That will take too much time for prototyping of some of the ideas to test some ideas. This iteration is too slow for current many of the statistical methodology development. If we can think in certain way, make post computation is much more easier and in a more engineering way, like you put in the Legos to put them together, that will be very helpful. And in the statistical computing, I think that currently I didn't see we put a lot of attention on that part. But on the other side, I think we put too much attention, for example, in the how we can make this a little bit fast. I like Julia, this kind of much faster. I also program extensive in the C++, that's really faster. That is useful in certain area. For example, we do the embedded device, embedded programming. But compare with the first problem I just mentioned in the how we can quickly to prototyping some statistical new ideas into the modern work. That improvement is only happen in the later part of this kind of speed in the Julia C++ is not that important unless you really want to deployment the solutions in some of the kind of hardwares. So that is my general feelings in the statistical computing these days.
So you are saying the hardware part of the computing is not being emphasized at this stage, or should be an integration of hardware, software, something like that, right?
So I mean like we want to have a little bit more on the engineering my side, so they can quickly to prototype different of the algorithms, because that in the reality take most of our time and to try to prototype. Like the big success of the deep learning, I can quickly to prototype of my idea. I also feel like this is a very similar way as why the Bayesian method is very popular, because although I truly believe some people believe in the Bayesian method, but on the other side, there are a lot of people using the Bayesian method because they are using MCMC. They are can very quickly to get posterior samples, understand the variabilities, and quickly to prototyping their idea instead of truly to derive the asymptotic theory of some of the result. That makes the MCMC very popular. That is very easy to prototype idea. Deep learning is very easy to prototyping of some ideas in the computation. But currently, we lack of such environment on the computation to quickly to prototyping of many of other models.
Yeah, that's an interesting perspective. Yep.
I could add one piece of insight. I feel like it touches on both what Hannah and Haoda have said, but maybe from a slightly different angle. I was on another panel a couple weeks ago at a small workshop in Montreal that they called Data Systems Meets Data Science. And it was particularly looking at the interface of the systems and the engineering with the data science, statistics, AI, and ML. One of the things that was raised was this ever-increasing divide between those who have massive amounts of compute and those who don't. Right, and the things that you can do in those spaces, and then that is correlating with some of the things that Haoda talked about, certainly in terms of the types of experimentation you can do. Without that level of compute power, some of that experimentation, it does not run in a half hour. It runs in a much longer time, if it runs at all, if you don't have the massive amount of compute available. And then there's another correlation, which is that it also correlates with this dichotomy that I said earlier I'm not so happy about, which is the academic versus industry one. And so those are not good trends, because it means that our ability to produce students and have students self-learn in ways that they're going to seamlessly move into the requirements and challenges in some of these high performance compute and cloud-based architectures, that's going to be ever harder to do. And at the same time, the type of mathematics that one might want to do, for example, it was mentioned the theory that supports MCMC and whatnot, that also is going to get further away from us. At another workshop I was at last week to celebrate the 50th anniversary of McGill's computer science department, there was reference to a recent paper in their literature, in the machine learning literature, about, is it time to slow down? And the gist of that was essentially, are we driven too much by empirical results that we're able to get by rewiring something and then posting it in an article, and perhaps we're too far ahead of our ability to do a deeper look at things that may take a slightly different, more mathematical skill set. So that's a set of related points, but it's all about this divide that I think, if we don't figure out ways to navigate that divide, bridge it better, I think it's going to have a lot of implications, not only on the next generation we're training, but also on our impact in society and the things that we can do responsibly and whatnot.
Yeah, this is very important. Yeah, we rely on leaders like you to provide us a solution, Eric. I think now you have a nice platform to call out your ideas, right? This is
the leaders like me call out the problem. We're looking for the young bright minds to come up with the solution.
Right.
Yeah, we will.
So actually, maybe let me add on.
Yeah, please.
After Eric talk on this, I think it's also important as statisticians to think about architecture algorithm co-design. This is so important and hardware environment before we truly design the algorithms. So for example, the big success of XGBoost is they are kind of handle really, really large data in the parallel fashions and the kind of very large data in a very fast way, compare with random forest. So the question, for example, even the question is how can we design some algorithm, like even for the Cox models, how can we handle petabyte of the data? Is truly unknown at this moment. I was thinking if the statisticians and the statistical computing can think about this hardware when we design some software algorithms and think about the hardware environment, that would be also very helpful and to design a truly productionized, efficient computation algorithm.
Great, thank you. So, Hannah, Teresa, do you want to add something about your thoughts?
Yeah, off mute. I do think that this question can be very industry and field specific, actually. So I work in the health space, and one thing that I see, often happening is that because computational methods and computing power in general, and and like all of these packages have been built to help us do computing better and do statistics better. But the problem, so I think one of the issues though is that we are sometimes forgetting about the statistical theory behind the methods that we're implementing, because it's so like you can take data and you can throw it into XGBoost, you can throw it into any of these great machine learning methods that are out there right now. Run a simple logistic regression and you get some results, but we're kind of the statistics or the insight that you need to have. You can't completely take the human aspect out of the research that you're doing, especially in the health field. You need to be able to think about what's going in and what's coming out, and the interpretability of all of that. And I think sometimes I get worried that because these methods are so accessible to everybody right now, that there's not enough training to be able to, I guess, like think about that underlying the fundamentals of statistics there. Yeah. I know.
I like your point exactly. What I was talking about is analytical thinking really matters.
Mm-hmm.
Big data not solve you. Deep learning will not help you. So I mentioned to people, if you are going in a wrong direction, the faster your car is, the far away you from your destination. Deep learning will not solve your problem if your methodology, the direction is wrong. And people talk about big data can solve the problems. I often talk about task is to find a needle in a haystack. The worst thing you can do is to add more hay.
Yeah, I definitely share the same view. I think, yeah, definitely analytical thinking and engineering mindset, they go together. They work together, right?
Yeah, I think one of the things that gets lost, and I tried to capture it from my students maybe about 10 years ago, and I keep saying it as often as I can, is and it's probably partly the way we teach, is theory is thought of as one type of thing, and the applications is thought of as another type of thing. And theory is all about proving proofs or answering the questions that we're given. And that's not really what it is, right, in practice. So the expression I tell my students is theory informs principle, and principle informs practice. It's not about taking your exact n goes to infinity limit, blah, blah. It's what was the central limit there I'm actually saying, right? What is this result? What is this probability bound? What is it saying? What principle is it giving you that then informs your practice?
Oh, this is a great point. I think we have to show in the classroom more about how the theory drives principles and how principles informs application. We have to provide a link to students, I guess, right, Eric? Hannah, you want to add your thoughts?
I think that was probably the nicer quote. the one I had up my sleeve is a bit more tongue-in-cheek. That is a comment from Uwe Liggers from like 2007, but it's like, RAM is cheap and thinking hurts. So that sums up that sometimes as well. But I think I'm going to go with theory informs principle, principle informs practice.
Great. So, well, I think we have time to another question. Perhaps it's just the last question about. I think I would just give through an open question. So, how do you want to see data science or computing grow in the next 5 or 10 or 15 years? What's your vision about the field? I think we already touched upon some of the aspects, but in general, what do you want to see us grow into?
All right, I'm gonna go.
Please.
I want it to be accessible and inclusive of a more diverse set of peoples, and I'd like it to increase the useful amount, or like the amount of useful information. And I think open source is a good way for the tools, but it should also go together with opportunities to learn how to use them correctly and ethically.
Oh, that seems very, very important. Yeah. So we didn't actually touch upon the ethics issue and diversity issue. I think, yeah, definitely these are extremely important. So your thinking is about accessibility and also in terms of both opportunities to learn and diversity, right?
I think we'll all benefit from
Yes, yes.
more people bringing their skills and capabilities to the challenges we face.
Yeah. If we have time, we definitely want to discuss about how possibly we can help to embrace diversity and also enhance diversity. I think we could have some discussion if we have time.
Yeah, I want to thank Teresa for that. We definitely, I think that deserves much more time than the 30 seconds that the comment took to make. I was going to offer a self-perception suggestion, right? Which is, I think, a couple times on the call it was pointing out that statistical computing in the academic circles is often considered sort of a second, a secondary topic, or less important than the theory of math or whatever. But it's the statistics computing interface that is so central to data science, machine learning, AI, and whatnot. I think statistical computing as a field needs to embrace that, and in doing so, help the rest of our field embrace the perspective that they are at the center of where it's at. Right, statistical computing is actually at the center of where all of that growth and development is currently going on. We saw Hedley Wickham, for example, get the COPS award a couple of years ago. I thought that was a tremendous validation on a number of different levels. But the validation of that as research, his contributions as one element of this statistical computing and computing statistics interface, I thought was really, really important.
Yeah, actually, kind of, Eric, what you are just talking about is the music in my ears, and I want to exactly can talk about exactly the same topics. So I feel like these days, statistics is truly in a crossroad, and in general for our discipline as statisticians, we need to more focus ourselves on the big social impact. Focus on the impact that is really important. I know the theory is important, the proof, and some statisticians think themselves as a mathematician is okay, but in general, for the whole statistical community, we want to have better identities, and it's very important to focus on the impact. To make that happen, statistical computing is truly important. We need that's probably one of the most important directions in statistics, and to helping us to have a better social impact.
Which then goes back to the points that Hannah was making as well.
Yes.
Yes. Well, just that anyone that you want to see anything that that possibly important, but we miss in this discussion. We really have limited time. I hope we can go on, but I think our time is up. Anything you want to add? Just as something you want to say to the audience as a final words.
Oh, well, I think it's so great that you're holding symposiums like this, and that we have so many interested people here. And before I sign off, I just want to say, if anyone is interested in talking about career stuff or different paths, feel free to reach out to me via email or LinkedIn or anything. I'm happy to chat more.
Great, thank you, Teresa.
Mm-hmm.
I would just say thank you, Chen, Kun, and thank you for to the ASA computing section for holding the workshop today.
Thank you for organizing this.
Yeah, thank you, Eric. Thank you, Haoda, Hannah, everyone. So I think this is the perfect time to conclude. Again, thank you very much for our panelists, and the discussion was really informative and interesting. And we will later post this video on YouTube. I hope we can reach a broad audience. I'm sure lots of students and the next generation statisticians will benefit from this discussion. With that, we will also conclude this symposium. Jing, do you want to say something? So I want to just say that Jing really is the main organizer of the event. He started the idea, and as an ASA section, we don't have a geographic base, but we thought it's a good idea to have a mini symposium every year, and so that we can have a discussion and then bring together our members. So Jing, please.
Well, thank you, Kun. I'd like to take this opportunity to thank all the speakers, panelists, chairs, and attendees for spending time with us at this November Saturday. I hope this is useful, and I hope we can engage more of our students and members of the section, and we can make this event better next time. Thank you all. Have a good rest of your weekend.